Hey, I'm Kim Libreri, CTO at Epic Games, and today I'm going to host a bunch of presentations from companies that aren't just games companies. We're going to have a little presentation from our Epic team to go over some cinematic capabilities we've added to the engine, and then we're going to have a bunch of super cool visitors to show all the different things that they've been doing with Unreal Engine. I don't know if you watched this morning on the stream. Obviously, cinematic content creation is super important to us. We make lots of cinematics for our games. It's been a tradition at Epic, and we're finding more and more customers are wanting to do even traditional linear media with the engine. So what we're going to do is we're going to show you the longer-awaited sequencer, which is the replacement to Matinee. So I'm going to welcome Michael Gay, head of cinematics for Epic Games, along with Grayson Edge, one of our senior, fantastic, super muscly cinematic artists. And they're a little bit nervous, so cut them a break. I'm going to pass the microphone over to you. You're already professional. Okay. All right, here we go. There's your clicker.
I think we're good.
Oh, you can put it there then.
Yep.
All right. Thanks, everybody.
Right on. Hi, everybody. All right. Hi, everybody. As Kim was talking about, as the Unreal Engine continues to push games to new levels of visual fidelity, the lines between game production and film production continue to blur. So we're here today introducing Sequencer in the hopes of blurring those even more. So Sequencer is a nonlinear cinematic editing tool. As you can see, the interface is not unlike nonlinear editing software. So we have loaded up here the awesome Ninja Theory cinematic. I don't know if you saw our character demo, it was awesome. Please check it out online if you missed it. So what we're going to do, as part of our collaboration with Ninja Theory, we converted this scene to Sequencer. So what we're going to do first, for anyone that missed it, is play through it. And keep in mind, this is playing all live in Sequencer. So go through.
You can't put it into words. That moment when you look into the eyes of the one who is supposed to reassure you, make you feel safe. It only takes an instant. Fear swallows you before you have a chance to make sense of it. And darkness becomes a part of who you are. You killed him. Her world changed that day when the Northmen took him from her. Senua knows that there is no going back to how things were, that there is nothing to go back to at all.
Their gods can see into your mind. They will use this power to destroy you.
They won't stop me. I can still feel it.
Whatever's left of him, they will never let him go.
I'm not gonna let him rot here.
You're the one rotting here.
Leave me alone.
You will die here.
No.
And all your suffering will have been for nothing.
Dillion? Is that you? I'll find you, man. I promise.
Every time I see that, it's more impressive than the last. So what we're going to do is take a look at this sequence and how we view it in Sequencer now. So Sequencer, like we mentioned before, is similar to a nonlinear editing software. So as the film and games merge, we're going to start using some of the same terminology. So here, if you take a quick look at the interface, up top we have shots. We can zoom in there. These shots have thumbnails, and it acts exactly like you'd traditionally see. The only difference here is when we're scrubbing here, we're not scrubbing images and movies. We're scrubbing actual full 3D scenes. So Grayson, you want to dive into one of the shots just to show we're live and in the engine? So all this is happening obviously in the Unreal Engine. Because of that, this is the first time we're able to move around complex cinematic sequences. And in a minute, we're going to show you about how easy it is to create a shot, move shots around, and experiment editorially with the piece that you're working on. And this is the first time we've ever been able to do that. And I think anyone here who's used Matinee will see exactly how much of an innovation this is. So we're going to, now that we've kind of gone through shots a little bit, we're going to go ahead and create a new shot. And to do that, it's very easy. Just right-click, insert shot. We're just going to add a new shot. Sequencer does a lot of the behind-the-scenes work, creating directories, creating all the shots, things of that nature. So what we have now is an empty slate of the shot. First thing we're going to do is add a camera to that shot. And with Sequencer, we've taken great effort to make sure that all of our cameras behave exactly as they do in the real world and look exactly as they do in the real world. So as part of that, we've included several real-world camera rigs. In this case, we're using a rail cam. So let's try something where we do just a quick shot of this tree. The tree is like a big feature in the piece. So we're going to do a little close-up on that, and then we'll go back out to the cut and then get back into Senua. So as Grayson's laying that out, let's talk about cameras. So cameras are the most important part of one of the most important parts of your cinematic. In a lot of cases, it's one of the actors. So what we've strived to do with Sequencer is make these cameras as physically accurate as possible. They have f-stops. We have a wide selection of film backs that you can use, everything from IMAX to digital SLR to Super 35. And all of these have been calibrated very accurately and respond perfectly to proper f-stops, proper focal distances, things of that nature. So as well as cameras, we've included a whole series of lenses. So we're setting up the shot here. Looks like we're are we focusing on that? Yeah, let's back that off. Can we set the aperture something around 1.4 to really blow out this blur effect? So as you can see, it responds exactly as you would want and expect a real camera to respond to. So we set that focus manually. So we've included a bunch of tools to make these types of things easier in Sequencer than they have been traditionally in the editor. So we're going to go to the end of the sequence here. And we're going to use a new tool that's like an eyedropper focus, kind of like when you're using your iPhone. You click on something and it's in focus. So I mean, this is like stuff it's been really difficult to do in the engine before. And we've also included things like tracking focus to an object, tracking the camera to an object, having a follow cam, having a sense of having that camera track from one actor and then go to another actor. Things to make it really easy to make compelling looking cameras. So let's take a look at the shot. In almost no time, we've created the shot that has a pretty solid shot. I mean, we've got depth of field, we got on a rail cam, but this has a symptom of a lot of cameras that are done on the computer, right? It is pixel perfect. So if we play through that again, it is like perfectly smooth, butter smooth. So you can imagine if you were on the shore and you have this huge tree and the wind's going and you lay down your track, it's never going to be this perfect, right? So another thing we've added is a way to add camera shake or camera animation just very quickly to a shot to just give it a little more character, give it, make it a little dirty, as they say. So Grayson, maybe drop a little camera shake on that, and maybe just zoom in, play through that. All right, this may be a little excessive, so maybe we'll back that off to. We'll probably fire that cameraman. So let's back that off about a quarter. And see what we got there. So the cool thing about these is this can be stacked, right? So you could have just, what we're trying to do here is just put maybe a little bit of shake because the rail wasn't perfect or bounced on the shore. So the other thing you could do is stack these and have like explosions going off, or maybe if you're doing a crane shot and the crane's affected by it. So we wanted to pay a lot of attention to cameras in this because we're trying to make a professional tool, professional grade camera tools, response, and effects. So that's one thing we're trying to distinguish Sequencer and get this meld between games and film. So, all right, so now we have this shot, and so let's see how it looks in the cut. So we're just going to back out here. Right now, it drops down the end of the shot, or end of the sequence, but through the power of the nonlinear editing, basically just drag that over, slide the shot over, and anyone who's used Matinee to do this type of thing, you can imagine how much of a time saver this is. So now we've just dropped that shot in, and now we can look at it in the context of the cut. Very cool. So what we're going to do now is, now that we've shown you how easy it is to create a tool, and all right, we just spent like 5 minutes making this shot, right? Imagine if you using the same type of tools, you spend all day making that shot, or you spend all day making 5 shots. This is exactly the type of tools that we're trying to do. We're trying to put into a sequencer to make this faster, make your sequences come together faster and look better. So now that we've done a little bit of making a shot, we're going to see what it's like to add to a shot. So as we mentioned before, we have this concept of shots and takes, and we're adopting this very film-like workflow and nomenclature. So what we're going to do now, we're just going to take the shot and add a take to it, just like you would if you were traditionally shooting a movie. So just, again, sequencer handles all the back-end stuff. Just hit enter, creates a new take. So let's spice this thing up. You want to drop a little bit of fire in there? Put it wherever you want. So a lot of times when you're creating a shot, you want to do iterations on that shot. What Sequencer does is allows you, in a way never before possible, to make quick iterations. For every shot, you can have 5 different takes, and view them in dailies and comment and pull them out, and again, see your results in real time. So Grayson's just add a bunch of fire to the shot, and let's say we show it to the director. The director is like, whoa, the fire comes way later. What are you guys thinking? And like, oh, well, let's try like after the other shot. So let's swap the shots. Let's swap that with the following shot. Maybe we'll put it a little bit later. Maybe that'll work. And so as you see what we're doing here, that's really easy in traditional editing software, right? Because everything's rendered out. It's just images. In Matinee and in the past with Unreal, it's been very difficult to do that. That might take, just that simple drag might take a couple hours, depending on how complex that sequence is. So let's say we didn't like the fire. So now we can just go back here, roll back to take 1. In this example, it was very basic. We just added fire because it's a very quick demo. Take could be anything from a new camera, new post effects, different animation, different facial animation, different audio. All these types of things are possible with takes, and that enables you to have a much better creative process. You get to try things more, and as we all know, with more iterations come better things. So that's kind of a way to look at a traditionally created cinematic. We're about to show you a new tool in the engine which allows you to record live gameplay and start creating cinematics directly after that. So I'm going to go ahead and close that. Pop on real time and off real time. All right, cool. So we are, this next map, we're going to be in Agora, the beautiful jungles of Agora. So Paragon goes live. You can buy and play that on this Friday, so early access. Let's go ahead and do that. So what we're going to do now is we're actually going to play Agora, or we're going to play Paragon, sorry, and we're going to record what we're playing. And this does 2 things. It gives us a really quick way to come up with awesome animation, and it gets us creating cinematics quicker than ever before. So while we're doing this with Paragon, none of what we're showing you is specific to Paragon. You can do this with your game. So in this case, we're going to select Steel. It's one of our favorites. So as we're running around the jungle here, we're going to go ahead and create a subscene in our sequencer. So you can see in the one window, we still have sequencer open. We're in the game. We're going to create this subtrack, which allows us to record Mr. Steel here. So as we just click the record button, and we've got 3, 2, 1, and action. I want you to take a left, go up the hill here. What I want to do here is try and create this idea of a jungle chase, right? So he's going to run up here, maybe does his ability, and just trying to get out of the way. We're going to have somebody else behind him. So get up to the top here, and then we're just going to stop the recording, just like you would if you're recording anyone else. And again, we're trying to make the parallels between game production, cinematic production, film production, video production, like transparent. All right, so now check this out. Now we're watching what we just recorded in the game. And I mean, that's pretty cool. So, and so the cool thing is, now we're seeing this from another perspective. Now we know if we wanted to do a retake of that, or if it wasn't good enough, we didn't hit our marks. Again, we're using a lot of film type stuff as these lines continue to blur. So let's take another look at recording another character. So we're going to go ahead and go back into the game, and you'll see something really cool here. we're going to select another character. This will be the other actor or the other performer in our cinematic here. So we're going to go ahead and start. But as we roll record here, you're going to see Steel. And so now we have someone we can match our trajectory with. Try and overtake him, things like that. 3, 2, 1, action. All right, just try and get up to him. I don't think you're going to be able to outrun him because we give him a pretty big head start. So, but don't worry, we can fix that in post, right? All right, so we're going to chase, beautiful jungle chasing, maybe get another slash in there. All right, cool. So now, you're just going to stop the recording. And yep, now we're going to check this out. So now we're going to see both of those actors going up. And again, we can figure out if this is the right take that we want to use. And you can pseudo interact with these people with these actors because they collide with you. So it's another way to help gauge where you should be when you're recording these animations. All right, so it looks good. I think we're good with those 2 takes. So now we're in a situation where in minutes of time, we've created something we can create a pretty compelling cinematic with. So you can do things like slide her, close the gap on Steel and Kalari there. And as we start to do this, you start to see the potential of doing this for replays or doing this for maybe with your game. So quick way to fast track yourself to some previs for your cinematics. So let's talk about cameras here. So we mentioned the cameras before, we didn't really dial into them. So Grayson, can you throw a Super 35 on this? Sorry, let's pull focus on him. Go up to a Super 35. So we've included all filmbacks or a bunch of filmbacks for a wide variety of lenses, or cameras, sorry. They'll pull back, and so as you can see, it's super easy, create these cinematics, get into a position where we're already lining up a shot. We went from 2 minutes ago, we had nothing, to now we're lining up shots in this awesome setup. And so actually, this is another very important distinction here. Grayson, could you dig into one of these shots? So what we just recorded for each of those players was actually everything they did. And this includes every effect they spawned, every sound they created, and every footstep they took. So it's recording skeletal animation as well as gameplay animation. So the potential for this to create awesome replay effects or awesome replays of events, and really start to dig in and create compelling cinematics. So that's about all we have to show. But we're going to be showing a lot more of this at the booth. We're going to be demoing it every 2 hours for the next couple days. And if you would like to see how a sequencer can help you tell your stories better, please stop by and ask us some questions. Thank you very much.
Thank you very much, Michael and Grayson. And Sequencer isn't the only thing that we've been doing for cinematics. We also have a pretty good replay system that was actually being used there that is incorporated into Paragon so that anybody who plays the game can basically, as a Twitch streamer, just do a replay of their famous moments and show their cool conquests in the game. And that technology is in base UE4, so all of you can do it when you're making your own game. We can have much more socially shareable content from gameplay that allows consumers to make cool-looking movies. Okay, so let me go to the next slide. Lost the other clicker, which is not so good. Am I back onto the slides? Okay, hold on a second. All right, so. Okay, I need the monitor here, sorry. Okay, great. So, for our next visitor, we're going to introduce you to Mark Roberts from McLaren and Francois Antoine from Epic. We've been working together on a little collaboration, trying to push the engine in terms of photorealism and seeing what it can do for design companies. So I'm going to shut up and let these guys talk. So speak to you in a little while, and welcome.
Thanks, Kim.
Thanks.
So hi, everybody. Great to be here. I'm Mark Roberts from McLaren Automotive. I'm Design Operations Manager. And my friend here, Francois from Epic.
Hi.
So we're going to talk you through a little bit about McLaren and the design process that we go through in the studio at the moment. But then we're also going to talk about the collaboration, the partnership with Epic, and what the cool stuff we've been doing, basically, that Francois and his team have been putting together for us, that's going to improve, optimize the way we design cars, basically. It's going to take us from the design studio tools right through to the customer experience, right at the other end of the scale. So I'll tell you a little bit about McLaren. Our goal is to be the iconic sports car company, to build the best sports cars in the world. You can see from this slide, it tells quite a lot about our history. I joined to do the car at the front, the McLaren, the legendary McLaren F1, 24 years ago. I always tell people I was 10 when I joined the company. We knew it was something special when we were doing it, but we just didn't realize how legendary it was going to be. These things now are changing hands for around 8 million sterling. They're highly prized assets now, and they're beautiful cars. At the other end of the room is the P1 GCR, which is pretty much the same design brief, but with 20 years more technology built into it. They are still the ultimate driver's cars. And all of the other cars in that room are showing the generations of vehicles we've built, 12C, 650, and which will lead us on to 570, which is our new baby, if you like. It's the sports series car. It was launched last year, and that's what's at the Epic booth this week. So I'd urge you to go and have a look at that if you get a chance. But we're just going to run a quick movie to show you a little bit about this car. So even though it's our entry-level vehicle, it's no slouch. It's 204 miles an hour, top speed, 3.2 seconds, 0 to 62. It's a V8 twin-turbo car with 600 newton meters of torque. It's pretty special. More important than any of that, though, it's so agile and it's so engaging to drive, and that's what our vehicles are all about. So I'll talk you through a little bit of the process. Whoops, that's skipped. Talk you through a little bit of the process that we use in the studio, and I'm going to take you through the next 2 or 3 slides quite quickly just to show you the design concept of the cars, the way we build and design them basically in the studio. We're a very small team. We're almost like a family unit, I like to think. There's only 15 of us in there. It's a mixture of clay modelers, designers, CAD, surface designers, and colour and materials specialists as well. So I'll take you through the next one. The process initially, this keeps skipping ahead. The process initially is literally blank sheets of paper, pens, markers. Sorry guys, we've got a little bit of an issue. Pens and markers just to do 2D sketches. And then very quickly, we refine those sketches. The designers tend to do about 10, 11, 12 themes initially. It's like a competition. They all want to win. They all want to be the one that's penned that car that you see in the movies, in the movie clip. They all want to be the one that's done the interior or the exterior. So it's a real healthy competition. This one is the one that won basically for 570. It was Project 13, we called it internally. But you can see from that, it's pretty cool that the guy who did that, Rob, absolutely nailed that concept. And we were so proud to get it into production. And it's hardly changed from that original sketch, which is no mean feat at all. So same for the interior, that progresses in the same way. 2D sketches, markers, and then we go into Photoshop and detail them up a little bit. And basically Photoshop is their sales tool to the management and the exec team in the business to get their theme to win. So as we progress through the 2D phase, we then take it into 3D, and we call this CAS, computer-aided surfacing. So the CAS process initially this is quite mature, but initially it's just built to intersects, it's just slab-sided, and it's just a volume model that we can quickly spin around. Because the sketch may look really cool, but as soon as you put it into the CAS and you spin it around, you think, oh, actually that doesn't work so well around the back, or you might start picking up things that you need to work on. So we can very quickly identify what's successful and what's not successful and what needs more work. So then, in parallel with that is the interior. So we do a full-size CAS interior, and we start to detail in around the hard points. We're given certain things like where the aircon must go, where the switch packs ergonomically must go, and we have to respect all of those hard points. So this progresses a little bit more in the CAS. And then comes the bit that a lot of people are surprised about, and in our kind of OCD, clinically clean world of McLaren, this seems like the antithesis of what we are. We mill into solid clay, basically. We have a steel armature, but we have about this much clay all over the surface of the car. It throws clay everywhere. It drives all the bosses crazy. You're treading in it. It goes all over the place. It's kind of the opposite of what we're all about. But it's like a necessary evil. It's the only way of turning that CAD surface into a physical model quickly, so you can then stand back and assess it. And human nature at the moment really is you want to run your hands along it and see if those surfaces are right. You want to get down and look at it, and you really want to sort of touch and feel it. So that's the next part of the process. So there's a sort of halfway finished interior, and we start putting in some of the solid parts, some hard points, some carryover parts if we've had to use vents or any particular bits. We've dropped an old seat in there until we've designed the latest one, just so you can sit in it and actually, again, touch and feel it. It's all about the confidence that what you're dealing with. So exterior, we start 40% scale models, about this sort of size. We find that scales up into full size really successfully, so there shouldn't be any nasty surprises. If you like what you see at that scale, when it goes up, you think, yep, that's fine. So what I love about this stage with the clay modelling is you've CNC machined the CAS surface into the model, but then you stand back for the first time and you think, maybe that needs to be a bit softer, or maybe this needs to be a bit sharper. And these guys, the clay modelers, have got such traditional hands-on skills. With these beautiful little tools, they start sculpting and they start looking at the surfaces and eyeing it up and just generally tweaking it. And the designer over their shoulder will be giving them a little bit of a lead. And then very, very quickly, they'll only work on half the car will start to come alive, and it's just that finessing that really makes a difference between a good car and a great car in terms of design. So from scale, we go up to full size. You can't read the highlights and the look and feel of the car as just bare clay. It doesn't hold the light and it doesn't transport the kind of the feel of it properly. So we put this film on it. It's like a stretchy film that you can paint. It's called Dynoc. So we cover it all in that, and then you can start to get a good idea of the light and shade and the form to see if what the clay modelers have done is absolutely right, or whether you need to actually modify it a little bit more. And then the ultimate test is to take it outside. So we put a bit more Dynoc on it to give it the impression of a glass house. But you can see from the car, the competitor car behind, there's no substitute for a real car. You can see through that, and it looks light and it looks real, whereas we're looking at 2.5 tons of clay and steel basically there. But it does get the impression across very quickly, and you've got natural light on it, so you get a good feel for it. And in theory, there's a lot more day-to-day to it, but in theory, that's the process. So now, what we're developing, and where it's getting really exciting for us, with Epic, with Unreal Engine, and with what Francois and the team have been doing, we're partnering to start developing some new tools. So visualization is what it's all about. And like I said earlier, it really is about getting confidence in what you're looking at, whether it's physical or whether it's with a VR headset on, or whether it's a really high-level quality photorealistic rendered image. You just need confidence to make design decisions. So that's what we're now starting to work on with the Epic guys. VR design tools for the studio, taking it right through to VR sales tools for the customer. And we're even looking at augmented reality for, say, things like Owner's Manual. We've had some good experience with augmented reality with some apps where we launch cars, and they've gone down really, really well. So that's an area of expertise that we've got some good experience in. But what we want to show you now in more detail is this best-in-class car configurator for the customer, basically. So I'm going to hand over to Francois.
All right, thank you, Mark. All right, so I'm going to go through, we've been building a car configurator. We're still in the early phases, trying to understand where the needs of the automotive companies are and where we need to change the engine to be able to use all that, bring it in. So it's been fantastic working with Mark and McLaren. Obviously, they have very high standards in terms of engineering and visuals. So in order to be able to convey the look of their vehicles in our engine, we've had to make some optimizations and improvements for high poly meshes in the engine. So some of those are these high-end rendering features. The first one being an improved ClearCate shading model. So within the addition we did allows to basically have interaction of the base coat with lighting. So basically, we are really having two normals on the mesh. And that's absolutely necessary for mimicking metallic flakes reflecting light under their clear coat and carbon fiber as well. So that's a feature that you guys will be getting soon. And all these features apply to ArchViz, games, and they're all very optimized. There's no big slowdown for any of these features. The other option is that we have an improved big GI solution, so we're with more accuracy, the 3-band spherical harmonics. We added distance fields AO, so that's a mid-scale ambient occlusion that occludes the GI rays that are baked into the scene. So that allows you to get like really nice occlusion on the big GI. And then we have also switched our mesh pipeline from a 24-bit normal to 96-bit equivalent compressed to 32. So we have much more accurate normals. You might not see a difference on low poly meshes, but as soon as you go to high dense meshes like you would get from importing CAD data, it's going to make a drastic difference in accuracy, and you'll get actually razor sharp UV edges and all that stuff in there. So big improvement there. We also, because cars are all about reflections, we increased the resolution of our cube map reflections and capture reflections. So we have up to 32 times the accuracy of reflections that we had before. That happens also in the G-buffer, so we have a much more accurate G-buffer. And then we did some other maybe less sexy improvements, but also very critical. So we now have the FBX scene import, which allows us to bring hierarchy into Unreal Engine. It supports instancings of meshes, and it maintains the import. So if you have to do a re-import of a whole scene, you can have material overrides and import, and all that stuff is saved as a data asset in the content browser, so it's basically lossless, and you can re-importing and do selective updates of certain parts of your scene. That could be used in entire levels or vehicles or anything. Also a big addition that we now support pivot points on objects. So if you've used Unreal Engine before, normally the pivot point, the object, wherever it is in the world, the pivot point's at the center or the origin. Now you can have the pivot point where it was modeled in your DCC app. So a big improvement. And then also what we added here is the Unreal messaging bus, and I'm going to show you that in a second. Basically what that allows us is to use an iPad here running Unreal Engine, a mobile version of Unreal Engine, and talk to another instance of Unreal Engine running on another PC. And the great thing about this is that there's zero configuration. It just works. This guy is sending a signal saying, hey, I'm here. And then the engine is basically saying, hey, is anybody here that wants to control me? And if there is, they just talk together and it just works. So yeah, we're going to jump in and see what that looks like. Can we go to the computer, please? And can we have audio? So if you head out to the booth, you'll be able to experience this for yourself. We'll have the car, we'll have the configurator. It's running at 4K over there on high dynamic range, images, Dolby Vision, so we get some pretty good accuracy. All right, Mark, how about we configure? You want to configure yourself?
Yeah,
beforehand?
Absolutely, yes.
All right.
So if you show us a base car.
Can we get video down here, please? Otherwise, I'm going to get a twisted neck here this way. It's going to hurt. All right, well, we can get started. So This is the car we have at the booth. So fully dynamic car. He drives in. It's proof. Nothing baked in here.
So I'm going to indulge myself then and configure a car for myself. So
All right.
I reckon we should start with what we do in the studio, and I think we should do a silver car because it's going to show off the line.
Really? You want silver in a car like this?
Yeah.
I don't know. How about this?
No, not green.
No
Silver.
green. All right. You sure?
Something much
No.
more subtle.
Okay, no orange?
No, not orange.
All right. Here we go. Blade silver.
Okay.
All right. Let's do standard silver. All right.
And I'm going to spend a bit of money on myself then, and I'm going to have some carbon on there. So I would like to start with, oh, that's good. So I'd like to start with, instead of a painted engine cover, I'm going to have a carbon engine cover.
All right.
You
So
do
we
that?
got 83 options we can configure here. So there's quite a lot. Everything available in the real car is available
So
here.
can we zoom in on that and see the,
Yeah, let's do that.
See the texture.
There we go. So we got the carbon fiber cover set up.
great.
there.
So
Using a new
I'm on a
code
roll
system.
now. So I'm going to
All
have a carbon roof as well. And actually, on this car, having a carbon roof is going to make the car look about, I'd say about 2 inches lower visually. It's a really nice option to have. It looks great.
How's that?
So to continue that theme then,
Man, look at the sharp reflection.
yeah, it looks great. So can we zoom out a little bit?
Yeah.
Yeah, that's good. I like that. Can I have some carbon mirrors, please? I'll stop spending
You're
it
a high
now.
roller. All right, here we go. All right, here we go. Let's zoom in on that. We'll take a look at those guys.
Right.
There we go.
These mirrors as well, by the way, even little subtleties, the mirror arms, we design them specifically so they guide the air down into those black high-temperature radiator ducts. We have this saying everything for a reason. So there's no styling on this car. Everything's designed. So even things like the mirror arms are actually performing a job of guiding the cold, clean air into that radiator duct. It's all about function. Form follows function with us. So I'm going to indulge a little bit more in your direction, but it's very subtle.
Are you going showy?
I'm going to do brake calipers.
All right,
So I
let's
think we
jump
should
around.
have. I think we should have orange.
Let's take a look at those brake calipers. All right, do
This is a
orange.
token gesture to your loud
thank you.
nature. And that's starting to look quite cool, I think.
All right.
So could you open the doors for me then, please?
All right. I'll do that. Let's get to the doors.
I love that the glass drops as well, exactly as the real car does. That's really
All
cool.
right. So you want to configure the inside, I imagine.
Yeah. So we've opened the dihedral door, which is another unique selling point of our cars.
Oh yeah, let's jump out and look at those doors.
Maybe you give us can you open the other one and maybe
Yeah,
just give us a front view? That's great. Yeah, that's really nice. Okay, so let's go inside. Even though I like that color, it's maybe not right for that car. So I'd like something, you're going to suggest something really brash again, aren't you? But
Can it be green? All right, green stitching.
whoa,
Yes.
no. But I like the black, but not the green stitching.
No?
We've got something orange to go with my calipers, I'm sure. Yeah, I like that. That's cool. And that nice baseball stitching as well. No.
All right.
That's good. I like that. And we've got Alcantara? Yeah.
Yeah. That's cool.
And also you can see the digital instrument pack.
How are we doing on time?
Yeah, let's just
You're
look at
out
just
of
zoom
time.
in. We've
All right,
even got
cool.
real time on the clock in the car.
All right.
Oh, we're running
Check
out.
out the little booth. We even got
I think we're
storage in
done.
here.
I think we've
So check it out.
What have you put in there?
I put that in there.
You didn't tell
You don't
me
know
that.
what that is. You
didn't
weren't
tell me
here at
about
last year's
that. I know
GDC.
what that is, but you didn't tell me you put that in there.
So
Fortunately,
last
these
little
guys,
thing.
These guys have it at the booth, so they can go and play it at the booth for the rest of the day.
So the big thing about this configurator that I want to mention is that you've seen other configurators like this in video games. Sure, this is more accurate. The special thing about this, though, is that we're bringing all the mechanical CAD data that's available on the car. So you can pop that out. And every single bolt, every single engine piece, the pistons are in there. Everything is in the car.
That's amazing.
And that's
really cool.
what you can do with the optimization of Unreal Engine. It runs very efficiently for a lot of meshes and polygons.
We're out of time.
Come on, I love this.
Okay,
Thank you very much, guys.
Thank
you very much. All right, well, I won't hold things up. I think the next presentation is equally as awesome, and I think is going to blow your minds. Please welcome. Oh, are we back on? Yeah. Okay. We need the left-hand screen. Sorry, guys. Please welcome Matthew Noyes from NASA, who's going to talk about some super groovy stuff they've been doing with Unreal Engine. But I'll let him tell you the details. Thank you.
So hello, everyone. My name is Matthew Noyes, and I'm the lead software engineer at the Hybrid Reality and Advanced Operational Concepts Lab at Johnson Space Center. And I'm here to tell you about some of the exciting work we're doing to create a holodeck-like capability at NASA using the Unreal Engine. So NASA is currently embarking on a 15-year journey to Mars. Our path forward includes development of commercial cargo and crew systems for low Earth orbit, continuing our scientific advancements aboard the International Space Station, and completion of the Orion capsule and Space Launch System, which will take humans deeper into the solar system than ever before. Unfortunately, going to Mars requires new technology and training capabilities, both of which will cost money. From a technology standpoint, especially in regard to control surface layouts, iterating many physical prototypes and interpreting analysis can be quite expensive, as is the creation of reasonably good physical mock-ups for training our crew members. So how can we reduce these costs? Well, one option is to build a system like the holodeck from Star Trek. Now, in an ideal world, the holodeck is the perfect simulator and could allow for control surface usability studies to be conducted virtually without having to produce extremely costly high-fidelity mock-ups. We've often heard VR headset developers state their desire to create a holodeck-like experience, and that's not a bad comparison. The quality of visual and auditory facsimile is astounding, even at this early juncture in consumer VR. But there's still something missing: the tactile feedback of real-world objects, the sense of pressure, of surface texture, and of inertia. Today, technology is not good enough to replicate these essential characteristics of matter. What we need instead is to use inexpensive materials to create rough mock-ups of physical objects, track their positions in the real world, and project high-quality renderings of them in the virtual world so that when you reach out and touch something, you can both feel it and see it. And this is the realm of hybrid or mixed reality, the fusion of the best parts of the real and the virtual to create nearly seamless presence. At the Hybrid Reality Lab, our goal is to create a low-cost, scalable platform combining the necessary elements to make our astronauts feel out of this world. The first of which is head and body tracking and visual feedback of motion. Now, NASA has been involved in some of the earliest research into virtual reality. Here you can see examples of headsets and data gloves created during the 80s at Ames Research Center. It's really interesting how strikingly similar today's consumer headsets turned out to be to these early designs. And here we have some examples of NASA's current use of VR today, with custom-built head-mounted displays and in-house software rendering packages to help astronauts train for difficult and dangerous missions. And then we have consumer VR, like the HTC Vive shown here on astronaut Terry Virts. The state of consumer VR is very similar to commercial spaceflight right now, where some of the earliest R&D was done at NASA. Then private industry simplified, polished, and added its own innovations. We can then reintegrate the robust tech into our systems as we look toward the future. With strong visual quality and a unique room-scale tracking function in Lighthouse, the Vive was chosen by our lab for the first iteration of our system. The next step is recreating the sense of weightlessness and tactile feedback. Right now, our sister branch is completing development of the Active Response Gravity Offload System, or ARGOS. Now, ARGOS is a unique robotic technology which attaches to a user via high-strength cable and offloads a fraction of their body weight to simulate Martian, lunar, or microgravity. A system like this allows for astronauts to practice navigating around the outside of spacecraft or along the rocky, uneven surface of other worlds with extreme precision. In terms of tactile feedback, astronauts will need to maneuver themselves in various micro-G environments using a series of physical handlebars that replicate the size, shape, and feel of the real thing. They can also use this system to practice procedures during extravehicular activities, such as drilling into a rock for a mineral sample. And lastly, we have a need to visualize our training scenarios with photorealistic graphics, physics, and multiplayer capability. And that is where game engines like Unreal Engine come into play. Truthfully, a hybrid reality training mission is not that different from a game. In both cases, you must create a series of objectives under various constraints, visualize the world around you in 3 dimensions, interact with the environment and potentially other people while doing so. By using a cohesive, integrated editor for all of these features, we are able to deliver content to our stakeholders faster than ever before. And we've created a series of technology demos to showcase what hybrid reality with Unreal Engine can achieve. The first of which is the International Space Station. Now, working with other labs at Johnson Space Center, we have created a dynamic simulation of the ISS interior. The physics interactions you see are actually powered by NVIDIA PhysX. Now, we've shown this to real astronauts who have actually been on the space station, and they have been extremely impressed and strongly agree that the quality of interaction and of the contact model are very similar to what it's really like in space. Now, in a scenario like this, it's important to make absolutely sure our astronauts truly feel immersed in their training. The fact is, the stress you feel when your life is in danger is far different from the stress of failing a training mission, and that can compromise your ability to react quickly. In human spaceflight, the cost of failure is not just measured in dollars. It is measured in the loss of human life. And that is why we must make every effort to ensure virtual training is indistinguishable from reality. The first steps we have taken with the Unreal Engine and PhysX are definitely in the right direction. Now, we also have the ability to interact with workstations. We can either use completely virtual control stations, as shown here, where we manipulate a camera outside the space station, or we can create low-fidelity mock-ups to physically manipulate them in the real world while in VR. Our goal here beyond training is to rapidly prototype different panel layouts, do usability analysis, and help refine the design before producing high-fidelity mock-ups. Now, we currently have a very simple process to align real-world objects with their virtual counterparts. It's good enough that your natural proprioception, the knowledge of your body position in 3D space, is enough to grab an object without being able to see your body. In this case, we align models of handlebars by placing the input device on top of the virtual hardware, and then we place the physical hardware in the same position relative to the controller. This will allow our astronauts to navigate 3D space in Argos using actual physical handlebars. Furthermore, using the HTC Vive Lighthouse sensors and the standard Unreal Motion Controller library, we are able to track real-world objects. The goal is to 3D print inexpensive mock-ups of tools, replicating the weight and feel of the real thing, while using a photorealistic render of them in virtual reality. In this next example, we show a drilling procedure. The user opens a toolbox, grabs a bolt in 0G, and screws it into the wall using a drilling tool. This demonstrates how we can model different hand tools and functions inside of the engine, and refine the procedures necessary to conduct work in microgravity, such as increased spatial awareness, as your assets may just float away if you're not paying attention. Another fundamental capability is multiplayer. Here, my colleague and I are practicing passing stowage bags to each other in microgravity and placing them in a storage compartment. We can use a system like this to practice unloading unmanned station resupply vehicles. It also allows for better collaboration within NASA, such as having multiple astronauts train together in networked hybrid reality across many different labs with their own unique facilities at the same NASA center or at NASA centers across the country. It even opens the potential for new kinds of research and outreach. Today, you can watch astronauts work using NASA TV. Imagine what it would be like to spectate astronaut training in real time on your virtual reality headset. That's all extremely easy to do with game engine networking. While we have yet to establish launch plans for such a feature, it shows the possibilities of what the future holds for immersive outreach at NASA. The most popular destination on the ISS is definitely the cupola. The front row seat to the Earth. When we showed an astronaut who flew pre-cupola this scene, he was ecstatic to finally get to see it for himself. Yet another indication of the immersive photorealism that can be achieved with a game engine like Unreal. I would like to point out that all the features you saw in our system were powered by Blueprint's visual scripting. This new feature in the Unreal Engine has allowed us to rapidly improve our ability to prototype new features for our stakeholders. As part of the JSC 2.0 initiative, Johnson Space Center is working to adopt lean and agile development methods to improve efficiency and effectiveness. With Blueprints, we are able to iterate multiple same-day deliveries of new features for evaluation by our stakeholders. It's also very easy to learn, which is important. For example, after just a week of learning Blueprints, our student interns are able to produce long-lasting, reusable code for our systems. Now let's talk about advanced Argos visualization. Do you remember when I talked earlier about using Argos to train astronauts in low gravity? Well, it can be used in what we call a shirt sleeve mode, where it's clear that they could easily wear a VR head-mounted display. However, Argos can also be used with a pressurized suited subject. And unfortunately, as you can see, there isn't enough room inside the headset to wear a head-mounted display at this time. So we need to create a different solution for visualization in this case. And one approach we're working on is the creation of a reconfigurable cave-like system called the video wall. Now, the video wall consists of up to 6 mobile towers, and each tower renders its own instance of an Unreal Engine scene across 16 high-definition monitors simultaneously using a single NVIDIA graphics card. The towers are networked together and use a single view management system, which will modify their view frustra to give the appearance of a single large screen. Now, here we've placed several CAD models of the towers inside of a virtual reality headset, which gives a true sense of scale. Using Unreal's Scene Capture 2D component, we can project the same Unreal scenes that will run on the real towers onto the virtual ones. We can then conduct usability studies on tower placement to maximize immersion and field of view. We can also write and test the view management system on the VR headset before a single tower is built, and then deploy the exact same code to the real system very soon after, since they both use the Unreal Engine. Thus, in addition to helping improve our crew training capability, we also use the Unreal Engine with VR to improve the speed and quality of our engineering workflow. Finally, we have recreated the experience of driving an Apollo lunar rover across the surface of the moon. In this example, my colleague is conducting a walk-around of the vehicle prior to boarding. This is kind of like a pilot doing a pre-flight check before takeoff to identify nominal and off-nominal conditions. Now that we've boarded, we're ready to take it for a spin. The rover is controlled with a joystick, both in the real and the virtual world. Here we used Unreal's default vehicle movement class to simulate the suspension and drive systems. The simulation, like the physics system, is again very immersive and presence-inducing. The landscape was generated at a large scale using real NASA height map data from the Apollo 14 landing site. For the control mechanism, we took an inexpensive gaming joystick and removed its handle, and then 3D printed a replica of the original Apollo joystick. This further demonstrates how we can create inexpensive but physically accurate models for use inside of our hybrid reality system. Had we wanted to use real-world assets only, the stick would have been made of metal and would have been much more expensive. And do these assets look familiar? Because we worked with NVIDIA to import the awesome models of Neil Armstrong, Buzz Aldrin, and the lunar module from the Apollo 11 Maxwell demo into our scene. And we're still working closely with them to integrate the latest GameWorks technologies, such as multi-res shading, VR SLI, and VXGI, to obtain better performance and graphical fidelity for our astronauts as early as possible. So let's recap. Using advanced commercial game engine technology and consumer-grade VR technology, we are working on a hybrid reality system which will provide incredible immersive and realistic training capability. We can use the same system to conduct usability analysis and write view management software quickly and efficiently, in step with hardware design, and iterate these features frequently with feedback from stakeholders, and deploy working software on new hardware extremely quickly. And by 3D printing low-cost mock-ups of tools and control surfaces and integrating them with next-generation graphics engines, and working closely with industry partners like NVIDIA and Epic to improve the performance to VR standards, hybrid reality will be an exciting, cost-effective, and scalable tool on the journey to Mars. And we've shown our system to a large number of people over the last several months, from politicians and medical professionals to engineers and many levels of NASA senior management. And the response has been extremely positive. Hybrid reality is here and has real applications in science and engineering, and it's all because of you. So thank you, all of you, because every time we as gamers demand innovation in this industry, and every time we as end users give feedback to improve the Unreal Engine, and every time we as open source developers push new patches and features upstream, you are making a real and long-lasting contribution to our space program. So thank you.
That was awesome, so good. That was an unbelievably interesting talk. I think our future in space is in very good hands. For our final presenter, we're going to keep it it's reasonably short and sweet because he's got a lot of secrets he has to keep. My friend Bei Yang from Disney Imagineering is going to talk about what they're up to, and it's a good one, this. Thank you.
Is the clicker?
Oh, you need the clicker. There we go.
I got one, all right? Can you guys hear me? Yeah? All right, thank you very much, Kim. My name is Bei Yang. I'm a creative technology executive at Walt Disney Imagineering. And how many of you guys, by show of hands, have been to Disneyland or Disney World? All right, good. The large majority of you guys. So for those of you guys that don't know, Walt Disney Imagineering is responsible for the design and implementation of theme parks for the Walt Disney Corporation all around the world. Now, one of the things that we kind of believe above all else is the fact that storytelling is best done through immersion. And what do I mean by immersion? I mean really putting our guests into the environment that they want to be in and doing everything in terms of what they see, what they touch, what they smell, what they eat, right? And we've been doing this for about 60 years. And of course, to do this, it requires hundreds of disciplines to be able to build what are effectively these cities. In fact, this is a picture of our newest Shanghai park that's opening up this year. And of course, we look at all aspects of this, right? We look at things like the way that you interact with each other, the way that you play, the way that you connect with your friends and family, and of course, the way that you eat. This isn't only limited to theme parks either. We also have, of course, cruise lines and hotels. Now, I want to stress that these aren't just places. We really see these as canvases for better storytelling. And one of the ways that we tell stories is, of course, through placemaking. Now, this is a picture from Radiator Springs Cars Land. We wanted to immerse our guests in the world of cars. So, of course, we built out Radiator Springs. So details and placemaking is certainly important, but technology is also important. Now, I have the very fortunate privilege to work within Walt Disney Imagineering Research and Development, a group of very talented artists, engineers, programmers, and we're all really living on the bleeding edge of technology, and we can kind of live a little bit in the future. And I'm super pumped about that because we can do all of this stuff all in service of helping immerse our guests. Now, we can't build a Radiator Springs all the time, because let's face it, we can't build those physical sets all the time, so sometimes we have to turn to digital imagery. Now, technology has gotten much better in the last few years, and we can have better imagery, we can have better robotics, and we really see these as new tools kind of pushing the boundaries to help us tell stories. And of course, with better imagery, we are now starting to see VR experiences. And if you were here maybe at GDC last year, you may have gotten a chance to see my talk, where I actually talk about how Imagineers have been using VR for the last 10 years. And of course, VR is something that we're really excited about, but another thing that's really exciting about VR is the ability to provide our guests with interactive experiences. Now, how many of you guys have gone to Disney's California Adventure or Orlando, Florida, and actually have ridden this ride, Toy Story Midway Mania? Yeah? All right, got some fans, that's pretty good. So we think that interactivity is just another tool in the tool chest to help us tell those stories, right? I mean, I grew up a gamer. You guys are all gamers. We're at GDC, right? It's pretty cool. We obviously want to give our guests that interactive experience. And having all of these tools in the tool chest has come at a very important time because we now have a very important task at hand, because some of you may have heard, but we are in fact working right now on a Star Wars themed land that's going to be in Disneyland Park in Anaheim, as well as Disney's Hollywood Studio in Orlando, Florida. Now, this is something that I've personally been dreaming of, the ability to actually step into the Star Wars world, and this is something that we take with great pride, and also it's a privilege to be able to work on this. And of course, one of the things that you want to be able to do in our Star Wars themed land is to be able to go inside the cockpit and actually pilot one of our favorite freighters. Of course, what I'm talking about is the Millennium Falcon. And this is precisely the thing that we are exploring right now with the help of ILM X Lab here in San Francisco using the Unreal Engine. So I'm going to play a clip right now that's just showing a little bit of what we're going to do. So all of those stuff powered in real time by the Unreal Engine. So thank you very much. I'm going to turn it back to Kim. My name is Bei Yang. Have a very good GDC, everyone.
Thank you very much. And Bei's hiring, by the way. Okay, well, that's it really from us. I think it was a nice, exciting view into a bunch of different uses of the engine. Hopefully we'll be able to bring some stuff like this next year as well. So thank you very much. And sorry we ran only a little bit late. Thank you.